The next item we're going to discuss is this topic of conjugates. Now, a conjugate is simply the same thing with different signs. Let's start with some pretty basic ones. The conjugate of the square root of 3 plus 1, the conjugate of that is the square root of 3 minus 1. Now let's start with maybe a more difficult one. Negative 7 plus 5 square roots of 3. What would the conjugate be? Negative 7 minus 5 square roots of 3. Let's make sure we understand one more time. Let's say I have 5 minus 3 square roots of 2. The conjugate of that is 5 plus 3 square roots of 2. So it's the same items with a different sign in the middle. The reason these are helpful, make a star, we use these to get rid of square root signs. Alright, let's go ahead and check a couple of denominators that have binomials. Alright, so if your denominator has a binomial, you're going to multiply top and bottom by the conjugate. Multiply top and bottom by the conjugate of the denominator. And that's going to get rid of your square root on the bottom. Yesterday, or in section 2 of chapter 10, you learned how to get rid of it when it's a monomial. Today, your denominators are going to be a binomial. So what you should do is you should compare today's notes, today's rationalizing, with 10-2 rationalizing. Okay? You should compare today's rationalizing with section 2's rationalizing. That way you know when to use what. Okay, well actually let's do an example. This would have been section 10-2. A problem where you have the square root of 3 over the square root of 2. Alright? Today you're going to have something like this. You're going to have like square root of 3 over 1 plus, or square root of 2 over 1 plus square root of 3. Okay, so the denominators today are going to have a binomial. Alright, let's look at problem 4. What is the simplified form? You see these square roots? You can't have square roots in the bottom. So what I'm going to do is I'm going to change that question mark into a multiplication sign, and I'm going to prove to you that using the conjugate gets rid of it. So the conjugate of this is the square root of 7 plus the square root of 2. So we do that top and bottom, so we're not technically changing our problem. Technically, we're multiplying by a 1. Now, let's do the top. All I see on the top is that I'm going to have to distribute my 10 in. So I get 10 square roots of 7 on the top, 10 square roots of 7 plus 10 square roots of 2 on the top. Now on the bottom, we're going to have to multiply our binomials together. Okay, so I'm going to do a double set of parentheses. I'm going to do this. Square root of 7 times the square root of 7 is the square root of 49. Square root of 7 times the square root of 2 is plus square roots of 14. Negative square root of 2 times square root of 7 is negative square roots of 14. Negative 2 times positive 2 is minus square roots of 4. Now what I'm going to do is I'm going to check out the top and the bottom. This is simplified, this is simplified. That's good. This and this cancel. The square root of 49 is 7, and the negative square root of 4 is minus 2. So the numerator, 10 square roots of 7, plus 10 square roots of 2, stays. The denominator is just 7 minus 2, or 5. Do you see how all of the outsides reduce by a factor of 5? This becomes a 1, a 2, and a 2. So I get 2 square roots of 7 plus 2 square roots of 2 over 1. So we just leave it as is. Next. Excuse me. What is the simplified form of this one? I'm going to change my question mark to a multiplication sign, and then I'm going to multiply top and bottom by the conjugate of the denominator. So I do the square root of 10 minus the square root of 5. Square root of 10 minus the square root of 5. The top, all I have to do is distribute. The bottom, I'm going to have to multiply both of these binomials together. Let's deal with the top first. Negative 3 times the square root of 10 is negative 3 square roots of 10. Inside with inside, outside with outside. Negative 3 times negative square root of 5 is positive 3 square roots of 5. On the bottom, 10 times 10 is the square root of 100. Next, 10 times negative 5 is negative square roots of 50. 5 times 10 is positive square roots of 50. 5 times 5, negative square root of 25. Now I'm going to fix anything I can fix. Both of these are good as they are, so they can just travel down. The square root of 100 is 10. The square root of 25, this is going to be a minus 5. These two cancel out. Here is a hint. If you're good enough, you will notice that you never have to multiply these because with conjugates, they always disappear. And that is why conjugates work out, because these are always perfect squares here, and these two will always cancel out. That's why the square root goes away. In the numerator, I have negative 3 square roots of 10 plus 3 square roots of 5. And on the bottom, 10 minus 5 is 5. Now please do not think that the 10, the 5, and the 5 cancel. This 5 is on the outside. That 10 is on the inside. You cannot cancel the inside with the inside or the outside with the outside. So let's make a note and let's write not negative 3 square roots of 2 plus 3 square roots of 1 over 1. That is not true. It cannot reduce by a factor of 5. This is as simplified as it gets. We're done with that problem. Problem 5 doesn't appear to have made it onto your notes. So probably what we're going to do is we're just going to do it right now. Or maybe we'll do it whenever we get into class tomorrow. But yeah, we'll wait till we get to class tomorrow to do problem 5 if we want. So go ahead and write problem, if you would, take a moment to write problem 5 down from your book. I'm not quite sure why it didn't copy over. Do that, and then if we have questions on problem 5, we can go over that.